My name is Himesh Words. I am a software engineer at Walmart. Lately, I have been experimenting with the local LLMs running on my own computer and not making any API call uh, to, OpenAI or anything like that. Using that, I have built a tool which is called AI Image Cataloger. What this tool does is basically it takes couple of images as an input, and what it does is it analyzes those images and categorizes them into multiple different categories. For example, if you have a product catalog, of clothing or accessories related to that, what one can do is can come up over here and upload all those images, and then this tool will categorize them into different categories of color, based on to gender or different kind of products, and then you can download those individually as a zip file. I'll show you the demo of the tool, how it is working, and then I'll also explain how this is working in the background. And as you can see that I am using Gemma 3 model, which is a model by Google, and they have multiple versions based on to different sizes. I have two models installed of Gemma, actually three models of Gemma. So let's try and use this. So I'm using Gemma 3 with 12 billion tokens, and I'll upload images, and then analyze those images using the model which is running locally in my computer. Now this definitely needs some power from the computer side as well. You would need some CPU and GPU power from your computer to analyze that. If you're running like a little bigger models, for example, currently I'm using Gemma 3 4 billion tokens, which is 3.3 GB, so it's not really bad. But when you are running like models which are really big, like some 27 billion tokens or 12 billion, so that would really affect your computer. So let's see if once the images are uploaded. So as you can see that these are the multiple images I have selected, and I'll just upload it to my local server which is running. And now I'll just trigger analyze to analyze these images, and this will start analyzing these images and start categorizing into different categories of what kind of product it is, for which gender is the product, or what color the product is. Now the categories I have currently in this version of the tool, I have defined only these three categories, but this can be definitely extended into multiple categories, or it can be dynamic also, where you can provide what kind of category you would need. Like for example, this is a fashion kind of catalog, so you have the relevance of color categorization is possible over here, and it is relevant also. But for something like sports goods, the color would not be very relevant. So for those kind of use cases, you can use different kind of categories. But currently, I have categorized these images into these categories. So as you can see that a couple of images has already been analyzed by the LLM which is running locally, and it has started categorizing into colors, different kind of colors, and for which gender what product is, and it is also categorizing t-shirts and shirts and polo shirts and things like that. So once all the analysis of all the images is completed, then you will be able to download only that particular segment. Like for example, now I want to filter out all the images which are there of shirt or t-shirts, like let's say what it'll do is it'll create this bucket, and then it'll put all the t-shirts into this bucket. And once this analysis gets completed, I will get a download button over here using which I can trigger the download. I'll just show you once this is completed. So it definitely takes some time in processing these images, as I'm using a node server, so it in the background it is analyzing one image at a time. And also, like couple of models, like for example in Gemma 3, Gemma 3 can take multiple images as an input to analyze, but it takes more power from it takes more GPU from your computer. It is always better to analyze, like give one image at a time to do the analysis. And other models, like I have tried Llama also as a model to analyze the images, and then this has been the support for two images or more than one image is not available for this model. So yeah, Gemma 3 you can use with multiple images, but it is always better to have like one image at a time kind of thing. So as you can see that the analysis is completed, and then these are the buckets which are created. Now if I want, I can download one particular bucket. Like for example, there are multiple images in the t-shirt bucket. So once this is done, I can do this, and product t-shirt.zip file is downloaded, and then I can check, you can download and keep these images separate. Where is this kind of tool is useful is where we have like a lot of product photo shoots, some kind of like you must have seen Mintra or something like that, where there are a lot of product images, and then the photo shoots are done, and then the images comes as a raw image, and someone has to sit through all the images and analyze those images as to and then categorizes them based on to that, or tag these images accordingly. So same way this tool does that work for you in the background. Now this tool can be definitely extended to multiple categories, as I discussed before. This can be extended into multiple directions for different kind of products. Now this is only image analysis of the kind of clothing currently, but mostly it can be extended for different categories as well. So yeah, this is the first version which I have worked on. This is available on my GitHub repo. You can go and check out my GitHub repo and try to use this. I will create another video, part 2 of this video, where I will explain how to set up your local machine on local Ollama, which is running currently in the background, which basically gives you endpoints to interact with the Ollama. Not Ollama, the AI models installed in your computer. So Ollama gives you that those endpoints to access those models. So yeah, I think that would be all for this video, and I'll continue in the part 2, where I'll explain the work, how it is happening behind the scenes. All right, thanks a lot.